Okay. So I'll take attendance in a minute, but let's just jump in and get started. We have one more problem to do. I stopped at 4A yesterday, and so let's do 4B, but it's just like 4A. So we'll zip through this, I'm pretty sure. All right, so somebody tell me, you can't hide today. Everybody's gonna get to participate. And we start. Well, first of all, I probably ought to switch my names. That's the key to the whole shebang. And you don't necessarily have to do that first, but we normally do. This is y, so x equals 2y plus 1 over y minus 3. Then, yes, exactly, Anna, we're gonna bring this over here, remembering that it's a distributive, so it's xy minus 3x equals 2y plus 1. Now, our goal is to solve for y. So remember the dilemma we were in yesterday, there's 3 y's. So what did we do to get ourselves out of that situation? These guys right here are going to switch so that all the y's are on the same side. Then we can take it out and divide. And we write our answer in correct inverse notation. So G inverse will be 3x plus 1 over x minus 2. Is that all right with everybody? You pretty good with that? Okay. Let's look at the next page. Now, a lot of this is repeat of what we talked about yesterday. Let's just go through it and make sure. We know that to find an inverse, we simply switch the x and y. Yep. Graphically, this means that a function and its inverse will be reflections over the line y equals x. So then he gives you a couple of options. I told you yesterday how I like to graph them. I just take the original points and flip-flop them. And for me, that always works. But another option is to go ahead and draw in the identity line, the line y equals x, and then graphically reflect each point by drawing a line perpendicular and extending it an equal distance on the other side. To me, that's more work, but for me, it's more work. It might work for you. So, one way or the other, would you sketch, in example 5, would you sketch the inverse of those two functions on your own paper? Using whatever strategy you want, you're going to sketch the inverses. maybe use a different color and grab whichever one you're doing. I'm going to grab my blue marker, and I'm just going to go ahead and kind of draw in the identity. Looks pretty good. Looks pretty good. Everybody okay with that? That's kind of what mine look like. Think about it, you switched X and Y. Does it make sense that a parabola opening up would now be opening sideways? Yes, because when you switch X and Y, you go from being X squared to being Y squared. What do you think would happen if this parabola had opened down? It would open to the left, exactly. Very good. Both of these are examples of functions that are not one-to-one. Remember that conversation yesterday? My function that I drew is a function. Anna's is not a function. Because in mine, if I draw a horizontal line through mine, my black picture, notice how it hits twice? That means those two Y's are repeated, which is fine, but not when you flip-flop them, then they become repeated X's. And the same thing happens with radius. Okay, good. All right, if you plug a number into a function, it generally will output a new number generally. For example, if we plug 2 into this function, we get 5. Now, if we plug 5 into the inverse, we should get 2. That's what inverses do. They flip the X's and the Y's. So if 2 gives you 5, then in the inverse, 5 will give you your 2 back again. This is because an inverse function undoes the original. So if we plug X into a function and then plug the output, we should get our X back again. That is the key. That's the main idea. Because the next task is going to be to prove that 2 things are inverses. Okay, so remember what it means to be an inverse. It means that if f of 2 is 5, then f inverse of 5 will be 2 every time. So whatever you start with originally is what you end up with when you do the composition. So f of f inverse of x must be x. So let's look at, and vice versa, So let's look at the first problem. It says, or example 6, f of x equals 2x minus 3, and g of x is 1/2 x plus 3/2. Somebody is claiming that these two are inverses. If you are doing this formally, you must use this idea of composition. So he asks us to find f of g of x. Well, you know how to do that. That means we're going to plug 1/2 x plus 3/2 into our f function. So 2 x plus 3/2 minus 3. Everybody with me? So let's clean this up. See, that's going to be x plus 3 minus 3, so that is x. That's what has to happen, but it has to happen in both directions. So, because composition is not generally commutative, we can't rely on just one of the orders, we have to do the other order too. So now we're going to do g of f of x. And it better be x also. So we're going to take f of x and plug it into g. And see what happens. Oh, did it work? That's your proof. That's how you prove it. We don't prove it with a single number. We have to prove it in terms of building both compositions and ending up with the same x that we started with. All right, so do that last one. Or no, it's not the last one. Do example 7. See if you can do example 7. Same way, same thing. Don't worry about that conversation about domain. We'll talk about that. You probably already have it figured out. But just go ahead and do the problem the same way we just did. Get it? Now, why did it have that conversation about domain? Because this function k, can't even exist unless x is greater than or equal to 10. We know that, right? It would be the same thing when you look at the next problem, example 8. They don't need to tell you what the restrictions are on the domain. You should know when you look at n that x cannot be 4, and then you look at p and x cannot be 0. So remember, when you prove things are inverses, you're proving it in terms of all x's. If there are x's that it won't work for, you have to make that notation, okay? So, do I have a volunteer, or maybe you all want to come up and do it together to do example 8? It's exactly the same thing, you're just using functions that have fractions in them now. Anybody feel like you can do this? Thank you, Raina. Come on up. You got a partner if you wish. Or you can go by yourself if you want to hog off the limelight. about that for a second, because that's a thing that happens sometimes. So step over here just a slide for one quick second. This is called a complex fraction. And you can clean that up in multiple different ways, but I think the easiest thing to do is to multiply every piece of the problem by x, because then we don't have that fraction down there anymore.
So we don't need to do it to the other side.
Oh, no, because we're doing, it's like having, if you have like, 2/3, can you multiply the top and the bottom by 2 and make that 4/6? That's what we're doing. We're doing it to the top and the bottom of the fraction.
So I would do mine by x minus 4.
Yep, you would do yours by x minus 4, which is a quantity, so you're gonna have to be distributed or whatever, yeah.
But now,
Okay, so what was that?
this is
That was plugging P into N. Okay. And that. So, I haven't done it, let's try it. So you plug P into N. So 6 over x plus 4. Wait, what's happening?
I just go.
I don't know. So this became 6x minus 24 over 6. I don't know what this is.
It was a 6 because I multiplied by 6.
No, because that would give you a 36 down here. So we're already multiplying by x minus 4 here because we had to get rid of this little fraction inside the big fraction. So this part is exactly right. So now this is gone. My denominator is 6. So write 6 there. And that is 4x minus 16. Okay, and so then this can become this fraction can become x minus 4 plus 4x minus 16. Okay, which is what, 5x minus 20? Okay,
That's it.
well, what is it, what did we just discover? What does this mean?
They're not inverses.
They're not inverses, because if they're inverses, when you do what you did, you both should have gotten the same, well, you both should have gotten x, not even the same thing, you both have to end up with x. Now, I wanna make sure we didn't make any mistakes. Did you guys get the same thing?
I got that they were inverses. I got x.
For the first one, you didn't have the minus 4.
Oh, Rena, did we forget something? Let's see, let's look real quick. Let's look again and make sure we didn't make a mistake right in the very beginning. We started simplifying this without checking to see if we were right. So, you get n of p. All right, so we're gonna take p, which is 6 over x plus 4, and we're gonna plug it into n. So it should be 6 over x plus 4 minus 4.
Oh.
So this is 6 over x, which you can either invert and multiply or times by x. Either way, you get 6x over 6, which is x. So yours works out. Now, I don't know what happened over here. Let's see what happened over here. So this one was p of n. So n is 6 over x minus 4. So p says take 6 over x minus 4 and add 4. Oh, that's what we do. So this 4 is not part of this fraction. So that doesn't get times by it. Only this fraction right here,
Okay.
because that's not part of it. Right? That's its own thing.
Okay.
So we're gonna times this by x minus 4. So we get 6x minus 4 over 6 plus 4, which is x minus 4 plus 4, so they are inverses. So we had a couple of arithmetic or omission errors there, but they are inverses. So you guys were doing exactly the right thing.
I miss a number.
You missed a number, you gotta have your whole function there. And then here, when we go to clear a complex fraction, we only clear the fraction, not other parts of the problem. Okay, so that's what happened, that's why we ended up with too much. Because you put that extra in there. Okay, perfect. All right, good job. This puppy thing, I just wanna make sure that you can do the math. And this would be with the calculator. So can you look at number 2 for a second? On the puppy, how much did you feed your puppy? Just look at number 2. Okay, so that's the question, but you have to look up above to get your formula. It says that this formula tells you how much food you should give your dog. That's the food right there. If you wanted to have a certain weight. Okay, so if you gave your dog 500 calories of food, you can figure out what his weight is. So number 2 is the backwards of that. It says if I want to make sure my golden retriever weighs 30 pounds or 30 kilograms, does it make sense to you that you would put the 30 in here? All right, I just want to make sure that we know how to solve that. So we're going to put 30 in here. All right, what are your thoughts on solving that? Actually, no, I'm glad you said that, because we only need logarithms when our variable is the exponent. If this was x, then I would definitely be using logarithms, okay? But let's not insert that complication if we don't need to. So no logarithms unless this is where your variable is. All right, so what's another thought? Anna?
Can you, put 30 to the 4 and then cube root it?
Actually, it would be the other way around. Because if we're trying to solve for k, this is a cube root right here. Wouldn't we want to cube both sides? And then take the 4th root? Does that make sense to you?
Yeah.
So what I would do is,
Oh,
I
so
would
you
just-
do what I said to the k if there was a variable in there, but since you're doing it across the whole side.
I would raise both sides to the 3/4. Because what do I do with these exponents? Times them, and now they're gone. So now I have k over 130 equal to 30 to the 3/4. So you can just raise 30 to the 0.75 power. And then times it by 130. Did you get about? What's that unit calories? Okay, so again, make sure everybody's straight on this. This is the easiest thing to do, raise it to the reciprocal power. That will get rid of that power for you every time. But when you think about k over 130 to the 3/4 power, or excuse me, 4/3 power, that means this is a cube root of something to the 4th. So if to get rid of the cube root, you would cube, and to get rid of the 4th, you would fourth root. So that's what that reciprocal power will do for you. Daniel?
K, the kilocalories per day, so you need to, convert it to calories.
No, but I should call this kilocalories. My formula is K is in kilocalories, so if I'll just say kilocalories.
Okay.
I don't even know what a kilocalorie is. What is that? I'm gonna call it that. Okay. All right, fact side. Okay, number one, based on the table below, what is G inverse of 12? Sissy? Because if G of 12, no, if G of 16 is 12, then G inverse of 12 must be 16. That's what inverses are. Everybody good with that? So use that same idea to do number 2. The graph of H is shown. Using just that graph, what is the value of H inverse of 2? Yes, because H of 5 is 2, so H inverse of 2 would be 5. Perfect, perfect, perfect. Let's do 3 just because you've probably seen these formulas before. Just solve that equation in number 3 for F. Get F by itself.
Wait, would you not switch the fair? Would
Yeah.
you not switch
Would not
that
switch
to
SAC.
Wouldn't that be like X and Y?
Okay, I want to think about this for a second. If I do that, let's see what happens if I do that. So here's the original. So if I do this, that, well, okay, let's go ahead and do that. So do this. Would you agree? Something about that's not right, though. Can somebody explain what that, okay, so explain why that's not right and explain what's going on under the scenes here that it's not working. What's wrong with this? What does this tell me? What's C? Temperature in Celsius? Doesn't this tell me, doesn't that tell me how to go from, if I have a Fahrenheit, how to get a Celsius? Isn't that what this is saying, the same thing? And they're not the same thing, right? So I mean, they are the same thing, but I can't find my Celsius temperature using this formula and this formula. It wouldn't give me the same number. So I shouldn't have switched the variables. Because if I just straight up solve that one for F, I get this. And what's this? This is how I go from Celsius to Fahrenheit. Now, I need somebody to tell me what's going on here. Why? Because I get it. I get totally what you're saying. Think about when I give you a function, like f of x equals, 2x plus 3 or something like that. And the first thing you do is make this a y, and then you switch your variables, right? And then in the end, you don't say x equals, right?
Yeah.
You have a y equals. But the y you end up with is not the same y you started with. This y is actually this y. So while we're using x's and y's and switching them, the x and the y have different meanings in the two equations, particularly the y in the two equations. So if I use the F and C and say F is Fahrenheit and C is Celsius, then I can't be switching them because they have to stay with their original meanings for the practicality of the science problem. This, when you switched your variables, this really became a new C that was really F. Does that make sense? You kind of see what I'm saying anyway? All right.
Why does
so-
the 5 not get distributed into the 32?
Okay, so let me go back and not switch those variables. Okay, so that was the original. Okay, so how did you go ahead and distribute? You can do that, you absolutely can. And then you added the 32.
So why does,
Oh, that should be 32 nines. That should be something bigger than that, not 32,
160.
160?
Yeah.
Okay, so then you gotta multiply by 9/5. So I get my 9/5 C, and then what happens when I multiply 9/5 times 160 over 9? They cancel, and you get 32. So the answer is you absolutely can distribute, but it's all gonna come out in the wash. I just went ahead and got rid of this first, multiplied by 9/5 right off the bat, and then all I had left was this, so I added 32. We're gonna end up with the same answer. All right, number 4. F of x is the distance in miles that an ambulance travels within x minutes. Interpret the meaning of F inverse of 26 equals 20. What does that mean in the context of the problem? Exactly. So after the ambulance has been driving 26 miles, it has spent 20 minutes on the road. The input variable there, the 26, is miles. The output variable is the minutes. So if the ambulance went 26 miles, it took it 20 minutes to do that. All right, let's do F real quick, find the inverse, and then prove it. Prove we're right. That'll probably be some kind of quiz question at some point. So step 1, find the inverse.
For which number?
The next problem, number 5, the last one on this page. Before I get too far into this, is this what you guys got for your inverse? That may be written differently. You could have written this 1 over x minus 2. It doesn't matter, those are the same thing. Everybody get something like that? Okay, so now we're proving it, and we're gonna prove it by building the composition. In either order, it doesn't matter, you have to do them both, so it doesn't matter which one you do first. let's talk about this. There's only 4 of us, so we have plenty of opportunity to share what's going on. Raina, what's going on?
I don't know.
Which one? Both?
No,
This is plugging
that one.
this one into that one?
No, that one.
This one? Okay, so this one is plugging, let me color code this. This one is plugging this into here. Now, which form did you use? Did you have 1 fraction or did you have 1 over x minus 2?
One fraction.
Okay, so that is gonna go here and here.
But the one that one was the one I was,
So this one over here?
no, this was,
Yeah, this is the one I'm doing.
oh.
So I'm taking my g function, which is that, and I'm plugging it into my inverse. So 1 plus, all that thing is gonna go here and here. So I have 1, so here's the green and the green. Okay, so 1 minus 2 greens over green. And then I had a complex fraction, so I think it's easiest to get rid of the denominator, just get rid of them. So I times,
Quick interruption.
yes.
Ron needs to report to admission. Thank you.
Okay, Kyle is a senior.
Thank you.
Who was that talking?
Mr. Ernst.
That's what I thought. So we multiply everything by x plus 2. That's what I did. So here in the blue, x plus 2 times this, x plus 2 times this, x plus 2 times this. Nothing happened here, so there's the x plus 2. Then over here, that fraction gets canceled out, so all I have left is the 2. And then down here, the whole thing is gone, so all I have left is 1.
That makes sense now.
Got it? All right. Anybody else? Everybody okay with this one? It definitely does get messy. So if it helps you to circle things and whatever, do whatever you need to do to sort it out. Good? All right, back of next page. We're not gonna talk about the summit, but we're gonna do the back of the
Wait,
next page. Yep.
So, for the one Raina was talking about.
Yep.
When you, like, multiply the x to get it out of the denominator, you multiply the plus 2, you multiply x to the plus 2 in the denominator as well. since it's
Everything
not-
has to get, this is a 3-part term here.
Okay,
So every part needs to get times by x.
even though it's not part of the fraction.
It is, it's part
it
of
is,
this
it's-
fraction.
It's in the.
So whatever I do to the top, I can do to the bottom. Now, if that 2 were hanging off the end like this, then I would not,
Okay,
but it is part of the fraction. Is that right?
Yeah.
Okay, once you get in the group, real quick, and I want you to do problems 1, 2, and 3. This should not take long. Get with your group. Talk to each other. tell me when you run into an issue or when you're ready to talk about these. This is yours. Mhm. Just put in this homework, which will be due on Friday, and that's December.
Yeah.
Friday's December.
Do you have any Christmas decorations for your room?
Kids are gonna decorate the back door, well, it'll be in the hall side, on the outside.
Uh-huh.
I got a tree back there, but I don't know if I'll get it out, I don't know where to put it, I don't know.
Put it right there.
Yeah. We got a few lights up at home, thanks to my husband, the nativity's out at home, but, we don't have a tree up or anything like that. Alright, let's talk about these real quick. What did you decide for question A? Is this is given the temperature of a town, okay? Did you think that was 1-to-1? No, why not? Exactly, very good, Addie. You can have a 50-degree temperature on more than one day. So maybe day 30 and day 100 both have the same temperature. Very good, very good. Now, what does that tell you about whether it's a function? Well, clearly it's not, right? Yeah, that's why it's not 1-to-1. Okay, now this next one. I went ahead and sketched my parabola. Is the inverse of that going to be a function? We kind of already talked about this. Is the inverse of that going to be a function? No, this does not pass the horizontal line test. So its inverse is not going to be a function. Support your answer with information from the graph. Okay, it does pass the horizontal line test. How could you restrict the domain so that the inverse would be a function? What is the domain of the original parabola? This guy right here, what's his domain? Everything, yep, everything. So that's the original domain. We need to restrict that so that the inverse is a function. So how could you do that? What would be a possibility?
Do you just have to like split the parabola in half?
Oh, yes, yes. Because, for example, what if we look at only the part of the parabola? So this is the original domain. What if we look at only the part of the parabola from 3 to infinity? Well, that would be that, right? Is that 1-to-1? Yeah, so its inverse would be a function. Now, it wouldn't have to be that half of the parabola. It could be the other half also. But that's how you would restrict it. So we look at only half the parabola at a time. Beautiful. And we see that even in our basic family of functions, because the squaring function, which is the parabola, looks like this. But the square root function looks like this. So it's only half of that parabola, because because its domain can only be positive. All right, and that brings us to number 3. So I went ahead and found the inverse. This is what I got. Did anybody get that far? Did you guys get that far?
Yeah.
Okay. So this is kind of the same problem that we're looking at here. So find the inverse and state its domain and range. Now, you have to be careful, because if you found this laying out in the hallway all by itself, you would say its domain and range are both all real numbers. But in the context of this problem, look at the original function. What is the domain of the original function? X has to be bigger than or equal to 4. And what is the range of the original function? Think about your y values. They're all going to be positive. Now, why is that important? Because when you talk about the inverse, this is what gets switched. So what is the actual domain of this function? It isn't all real numbers. It's actually only the positives. And the range is not all real numbers. It's actually from 4 on.
So when you're finding domain and range, you should look at the original.
Absolutely.
So don't
Absolutely.
make assumptions after.
You cannot make any assumptions from the inverse. It all goes back to the original. Very good observation. And we kind of saw this yesterday. We weren't doing inverses, but we were doing compositions. And when they said find, P of Q of 5, finding that in the hallway seems like, okay, an easy thing, just start plugging 5 in. But what happened to us yesterday, do you remember? Sometimes we couldn't, because it wasn't in the domain of one of the functions we were trying to use. Okay, so what this guy looks like is this. So when I find its inverse, it's just that.
So it's 1 to 1.
Yeah, that function's 1 to 1. Yep. Yep, it sure is. Okay, I'm done. So you have 4 minutes. You can start.
2.7's due Friday. I mean 2.8, sorry.
Yeah, 2.8. 2.7's due tomorrow, I think.